So your cheat sheet currently has all this stuff on it. We've got simplifying rational expressions. We've got excluded values on there. We have multiplying or dividing rational expressions. You should have, hey guys, at this point you shouldn't be talking. You should have common denominators, right? That was something you added on your own. Then together, the last thing that we added was adding and subtracting. And at this point, I am done with my first full sheet of paper. I covered the front and the back completely, so I'm moving to a second page. If you do not need to move to a second page, you're good. That's fine. But what we're going to add today is complex fractions. That was the last thing we did. We have not put it on our cheat sheet yet. So, complex fractions. The first step in complex fractions was always to make sure that every little part in the overall fraction had a denominator. So make sure all the fractions in the problem have a denominator. So we're going to put an example problem on here as we go. So if I had x squared over 3 being divided by 3 over x plus 9, what's wrong with this fraction right now? Yeah, the 9 doesn't have a denominator, so what denominator should I give it?
Over 1.
Put it over 1. So first step, we need all of the little fractions to have denominators. What is our next step? Yeah, find a common denominator. So, what would the common denominator be for this problem? 3x. So now that we know what the common denominator is, what should we do? We don't have it yet, though.
Distribute everything, or what the other fractions mean.
Yeah, so make sure that all fractions have the common denominator. And then once we have a common denominator for everything, what do we do with all those denominators? We ditch them all. We cancel all of them out. Okay. So then we're going to ditch the denominators. So this fraction on the top has a denominator of 3, and it needs to have a denominator of 3x. So what should we do to it? Yeah, multiply by x, multiply by x. On the bottom, this one has a denominator of x. What does it need? 3. It needs to be 3x, so it needs a 3. And this denominator has a 1, so what does it need? 3x. So at this point we ditch the denominators. I'm not going to fully scribble it out like I normally do because I want to be able to still read my notes. So once you've ditched the denominators, what do you do next? Kind of like combine like terms. We have some things to multiply, right? And so you can phrase this different ways if you want to. I'm going to say that I'm going to write the leftovers. Does that make sense? Writing the leftovers. So x squared times x. And then on the bottom we've got 3 times 3. And we've got 9 times 3x. 7x. And then last step, once we have it written like this, what is our final thing that we always have to do? Yeah, so simplify is the word, and what does it mean? It means to factor and cancel. And what is the type of factoring that we're typically going to see on this last step? GCF, what else?
Slide divide.
Maybe a slide divide.
Diamond.
Maybe a diamond. One more. Difference of squares. Yeah. And this one happens to be a GCF. So we have a GCF on the bottom. Is it helpful if we factor the bottom? No, it's not helpful. So you are welcome to factor the bottom if you want. You do not have to factor the bottom because nothing cancels. Okay, so you can leave it the way we had it. Or if you want to factor the bottom and say that's 9 times 1 plus 3x, both of these answers are equally accurate.